logging into chat because I had it off last time. Alright, today I'm just going to go over some finishing bits. I think I'm live. Yep. I'm going to go over some finishing parts. I was looking at a famous thread on op-amp outputs in modular in Eurorec. I was having a look at this, overlooking stuff about this. I remember reading somewhere about doing optimal things when you're driving a SAR AD converter, but I can't find anything on that. I'm looking at, I looked at perhaps turning these into low pass filters, but I want to keep them inverting because it means I can use one op amp and it has 100k input impedance. So I can't do a classic Salad key filter, but I might just change this capacitor value and make it a little bit closer to filtering out frequencies nearer the sample rate, half the sample rate, half the Nyquist of the ADC, but it's obviously it's going to be quite a shallow filter, but that's okay. But I was looking at, it doesn't really matter that the audio outputs have series resistors, but because these are CV outputs, it might be quite good to do the classic thing where you put the current limiting resistor there, like that. This one needs to be something like 220R. This is famous to modular anyway. DIY. Circuits. What am I doing? I'm inverting. For some reason I'm doing it with 20k. This is strange. I think I am doubling and then offsetting the signal because it says here somewhere V out is 0 to 4.096 volts. So the gain, double the gain to be plus minus ish 5. Oh, I haven't even copied those resistors across. There is something there. It's just I haven't been bothered to do it. I'll do those values later. But I do think I need probably want to put the feedback capacitor in as well. just in case. I might even just have them unpopulated. Oh, I've put that in the wrong place, haven't I? So it's sort of like that. There's a feedback. There's a low pass filter here to filter out high. It dampens any high frequency oscillations. And then with the output in the feedback loop, it helps keep it stable, and also means there's less droop on the output. So this would be more handy for when you're doing like volt per octave things, basically. So we just need to move these resistors. That it's getting a bit messy. I'll have to clean this up aesthetically later on. It basically stops it from oscillating and stops the effect of load on the voltage on the output, which is good for CV signals. Especially in this device, it will be ambiguous what exactly the CV is. What the CV is used for might turn out that someone will want a really precise CV output. I'll do another video later. I'm not really in the mood right now for doing all the maths. Now I'm thinking, oh yeah, these should be, it's still quite good to leave this to be quite a large, the output resistance is quite large, because even though op amps are short circuit protected, they like to, they do get quite hot if you short circuit them, especially if you're in a modular and you short circuit it to -12 or something. I've actually found op amps getting really hot doing that. But I'm going to leave the series resistor, well it's a RC filter, the audio output. I wonder if on the inputs it's probably nicer. Well, you don't want the resistors to get too big. No, I wonder if this is all correct. Don't know. And I also have thoughts about using an I/O expander. Because I might add LEDs, I'm not sure. Or I might just have LEDs that are driven off the output jacks, which is not wrong. It would save I/O, Anyway, now in KiCad, this is a stage that really frustrates people who are used to Eagle. Everything needs to have a associated footprint. By default, I'm using quite small capacitors. Weird, I'm using a mix of small and big. The 10p ones are small. 10 picofarad ones are small. Why are my resistors? Oh yeah, because these are not resistors, they're actually capacitors. But I'm putting a resistor, 0 ohm resistor in just to have them bypassed initially. I'm probably going to go through and refactor all the values at some point near the end. And the sizes of components too. Got some electrolytic capacitors. I should probably just do it. Got some electrolytic capacitors. This all seems fine for now. Oh, I've got these weird. Capacitor 0402. I'll convert them to my ones. Got a lot of components here. SOT 23, no, SOT 323s, polyfuse. A, B, C, fuses. Where is fuses? Circuit protection. Resettable fuses. Now, is there a value of polyfuse that they usually use on? I don't need to supply 500 milliamps, but I want it to work up to. See, how much power does a Arturia was it Arturia key step? Arturia, it is Arturia. Say Arturia Step Pro. Details. I need specs. It's got loads of LEDs on it. No, that's how to use it. I need the boring bit at the back of the manual. Where's the manual? That, for example, is right, specs is normally at the end, but nope. Where is specs? I thought we'd get specs. Never mind. What's USB 1? There should be a table. The connectors. USB 1 was where's the stuff? I need the stuff about current. USB port. Oh. I know I could look at the USB spec. Half an amp. We don't really have half an amp though. Let's limit. I'll just pull it out of thin air. Let's limit it to 250 milliamps. So we want it to trip at say 150. So we don't want it to trip any lower than that. No, that's resistance. 150 milliamps. I don't know if there's any so when you use JLC PCB parts library, there are free to install, there are free to place parts, and I wonder if any fuses are in that category. Basic parts. Nope. £3. I'll just take the first one. Most in stock. It's the NSMD 005, which is 100 milliamps max. Oh, 100 amps max before it explodes. When it holds at 50 milliamps. It trips at 150 milliamps. But it will probably be up to 250 milliamps. That's pretty good, I think. So I'll just copy that name, call it that, 150 milliamp. What's its package? It's a 1, so I can just use a 1206. like a resistor. Which I don't have, but I can just use it here. I use use a 126. Why did that just jump? Okay, audio jacks. These are there, but I've just updated my software. So I actually need to re-add audio jacks library. It's the library I make. Can't see what I'm doing because it's browsing my computer. Audio jacks. Footprints. Oops. Nope. Why is it not updated? I think what I need to do is actually close KiCad and reopen it. It's a bit silly. There you go. Now this is a funny part. This is from JLC PCB, and because I basically wanted to make a no solder kit, so no solder order. So you just buy everything soldered on it. That's the standard pin header. Oh no, is it? Oh yeah, I need to work that out later. This is the pin header for the display. More jacks. Oh, and USB-C receptacle. I did have a part in mind, but I think it's gone obsolete. I've used hundreds of these. I think it's... Yeah, this is it. It's called the 98 blah, 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 blah. If I just do that. It was a Chinese company. Oh no, they've still got some. It's really handy because it's vertical. It's not USB-C, it's not USB 3 standard, it's a USB 2 receptacle in USB-C format. So if you look, it only has, because proper USB-C connections have way more connections than this, because this is only D plus and D minus are only the standard USB communication lines, not the newest ones, the higher speed ones. And then it just has CC lines, which are for telling the charger, and then it says ground voltage, and it's all through hole, so it makes a really nice strong connection. So we're using that. Perfect. I think they might charge for those now though. And the annoying thing about JLC now is you can't tell if they're going to charge extra until you've got into the ordering stage. Does it tell you here somewhere? Some parts going to be done with jigs or something like that. Don't know. It cost 42p. Okay, so there's that. Inductors. Got to find those. Oh yeah, got to use that very special one. I've got those already. These are the MOSFETs. There's 2 unknown resistors, which are tiny O603s. I don't know why I've changed package sizes. These are O402. Oh, where's my O402 resistor? I accidentally deleted it or something. Oh well. I'll come back to that later. These are more resistors. Oh, these switches are very specific ones I found already. This is something I didn't do a video with. Did this before I started doing the videos. They're these, they're quite generic. There's quite a few different manufacturers that do these with the same footprints. It's basically a button with a really tall, well, this is 9mm. I'm not sure if that will stick out the front. I had to work out. Anyway, these are Alps rotary encoders. It's the same switch. These need to be the same. These two. It's in a local library for green screen. I think eventually I'll pull everything into a local library, so I can package it all up. See that at the bottom must be under G. PCD green screen. It's called a key SMD. Yeah. My QFN. My DAC. My DAX. Oh, this memory doesn't seem to exist anymore. Package SO, which it says it's not there anymore. Probably because it's a newer version of KeyCAD. It's a Sweek 8.5.3. Yeah. It says 5.3 and 5.23. Give that a go, but it might be wrong. That's a TSOP, MSOP. I need to replace these op amps. Got a voltage reference. Which just made me think. Ref 3033. Oh, recommended for new designs. Oh, it can only take 7 volts. Just thought it might be quite good to run it off 12. Regulators. Do not place. Oh no, I want to place that. I'll do it as the same. SO. But I might actually later on in the game try and. But I'll put in a Suic 8. Like I just did. For the other memory, 5.3. And it's not do not place. It's not do not fit. I'll just call it an SRAM. But I need to find an SRAM for it, basically. I won't do that yet. Comparators. Hey, it's pretty much all in. Oh, it's the crystal. Yeah. Okay. Apply and save. So now I pretty much, maybe not correctly, but I pretty much have a footprint for everything. And if I update this, should be a load of stuff that isn't in yet. Oh, funny, what are these? Oh yeah, my layout's a bit different. I don't know what to work on next. I think for tonight I'm just going to work on the main board and not the jack layout board. Just because it's what I'm in the mood for. I need to check my op amps. U6A and U6B, U13A, U13B, U20A, U20B, U21A, U20B, C. Oh yeah, do I have all the rails in? This is for U20, yeah. Oh yeah, and that's for U13. And that's for U6. And then on outputs, if you notice here, I'm not actually using an op amp on the output of the DAC, because it is actually at the correct voltage. It apparently can do 5 volts, 10 volts peak to peak output. I'd need to see if that's true. E-rate A, E-rate B, E17A, E17B, U18, U22. Yeah, everything looks right. Oh, on my USB input. Oh yeah, look, I haven't connected that. I don't actually need that because it's down here. USB DMDP. Oh, I've called them different things. Okay. Now to this chaos. What are these for? Are these my memory chips? These need to go here. I feel like my micro should go should go over this way. This connector here. And then my memory can be as close as possible over here. U15, is that the... No, that's the optional one. I want the real one to be pretty close. Oh, which one? Kind of hard to know which way round it should go. And my less important one here. These don't need to be... I don't need labelling to block. Oh, it should all go to the right. But where's my power connector? It's here. I don't know why my power connector is down there. I think my power connector should be as close as possible. Oh, I'm not sure if that needs to be an electrolytic. You think about this bit. I want my power connector to be here, I think. Negative at the bottom. This connector is... What's this then? Oh, that's a debug connector. This is systemic ET. That can go that way. This is a debug connector. Where's it meant to come from? It's there because it's a nice convenient place to come from. Then what's this? That's important. Oh, is this the power supply? No, that's some random op amp for my voltage reference. I want all of this circuitry to be close to each other. So I'll do pack and move. Oops. So power connector goes in there. That's for a random op amp. this is my 12 to 5 converter. Put it here. Then this is my 5 to 3 volt converter, which is going to drive over here. Then we want this capacitor to be really close to it on pin 4. I think I might have to go no designate. This one goes really close to it on the input. Do it like that. These are nice chunky multi-layer capacitors. Then this inductor's missing. This capacitor is important between 6 and 2 of the switching one. Kind of need the inductor. The inductor's probably going to be massive as well. So if you look on the not huge actually. Where is it? It's probably this. Where's the... oh, there it is. Humongous. Where's inductors? Power inductors. Let's do 3U3, 3R3. Okay, most popular, most available. Want a nice chunky 5 amp one. That's 8 amp. It's moulded. It'd be nice if it was shielded. This one's shielded. Let's filter out. Nah, let's not filter. Sometimes filtering filters out things you don't want to filter out. I just want one that's shielded. Because, I don't know. Here you go. Oh, that's not enough current. One amp. I guess shielded ones become bigger. Right, I'm going to filter by saturation current. I want 5 amps to 10 amps in stock. Molded. Could be shielded. But that's 4 amps. Molded. I might just have to give up on the shielded thing. And 4 amps is probably alright. You know what? Screw it. Reset. Oh, shielded. I can search by shielded. I have to also filter by see this one will be right, 4.95 amps. That's shielded. 20p. Ah, I like this one. Now I've got a little trick. I've got a little script that you can run to get the footprints straight from the JLC PCB library. So you just go. Oh no, we need the. And that just drags it all into, copies it all into a footprint, into a, KiCad footprint. I can't show you because it's on my computer. Really paranoid about showing personal information like bank details or whatever. So, oh, and then I just went and did it. Basically, I just have to copy those files into my local library that I made for this project. It also should have a 3D package file as well for it. It does. So you can't see this. And it's called SMDRH or whatever it's called. So if you go to this, And the inductor should be unhighlighted, I think. Yeah. I'll add it to both of them. Green screen. And it's called end. Oh, what was it called? End the footprint. End SMD L 10.4. 10.3. Yeah, that's it. These are going to be massive inductors that are suddenly going to appear, and we're going to have to find spaces for them. Here they are. This is the only downside of switching supplies. Oh, it might be a bit big. Oh, maybe I need to choose a smaller one. Stick it here though. Kind of a random hodgepodge. Wait, what's that one? That's our reference voltage. We don't need this to be here. In fact, our reference goes into pin 59. It's 59. It's down here. So we can move our ref chip down here. Well, maybe. You know what, I might have to move the power connector down here just to give us the space for this kind of stuff. And our other inductor, that's going to be on a different board though. That's going to be over here where there's plenty of space. But I'll get all this stuff, pack and move it, because this is all going to be here, and there's tons of space here for this kind of stuff. And look, this is kind of how it's looking at the moment. I've got the connector board here. This is going to be all a single panel, and then there's the microcontroller at the top, and then this is all the analog circuitry. Oh yeah, and I think the SD card is actually going to come through. Huh. Ah, that's a problem. It's going to come through two boards. I'm not sure if that's a great idea, so I have to rethink that one. And then this is the reset switch. It goes next to the USB connector, which isn't even here. The USB connector's here. And there's a USB host connector, which I'm thinking is somewhere here. Then all these parts are our output stage. What happened to our... We seem to have lost our USB pins that were coming underneath. Let's just... So I'm just going to sort out the power, and then I think I'm going to call it a day. So there's these two transistors. These are short circuit protection resistors. They come first. Transistors. This one is for 12 volts, so I'll just stick it here. And it has it should have electrolytic, just for a bit of bulk capacitance on its input. Don't know how big to make that. and then there's a protection MOSFET on the negative input, which I might just stick down here because the microcontroller doesn't need it, so it's better that it goes near the op amps, because they're the parts that really need it. So like that. This seems like it should go that way around. There's quite a lot of space here now. Then I've got a capacitor here. It goes on 3 and 5 of U12. Where is it? Three on its input. And I've got that 100M that goes between 6 and 2. I need to make a decision what to do about the reference designators, whether to turn them off or not. And the inductors there. Now that should be pretty close to the switch, I guess. Pin 2. It's not close at all. I wonder if I did that. And then I've got these two feedback resistors. These set the voltage. They need to go on 4. One goes to ground and the other one goes to 5 volts, which the output. Just pin 2. I might double check any tips from the datasheet, what it thinks. What was this capacitor for? Oh. This is a nice chunky, powerful power supply to get us 5 volts, and then a bunch of capacitance, put a big cap, a bit more bulk. Not sure if I need this many electrolytics. 5 volt output. Quite nice if it could go there, I guess. Wait a minute. That needs to be the other way around. And what's this? It's part of our voltage reference. This is an op amp. Now, what was I doing with the voltage reference? I was trying to get it close. Oh, I put it down here, which is good, I think. A couple of caps. Don't think I need that. I'll make that big. Why is that not? Relink, delete footprints with no symbols. There we go. And then I have this op amp just to create a negative version. It's probably quite good to leave some space around here for logos and stuff. What are these spare? Oh yeah. Just a bit of parallel capacitors on the output of the 5-volt regulator. Yeah. What's these? Oh, these are there are CC lines for the. They'll be on this board. Oh god, there's tons of stuff down here. That's our USB host stuff. Oh, that belongs to this. Where's this one? Here. This belongs to this. These are the pull-up resistors. Oh, they have decoupling capacitors. That would probably make bigger. This is for this one. This one. What's this? Is that for U11, which is, yeah. This belongs to this. This is decoupling caps. Oh, weird, that's attached to something else. That one's meant to be with U11. Here. Something like that. And is there anything around the chip? Where is the resistor with the switch? Where's this resistor? Yeah. Oh yeah, interestingly, it's going to be a long way that it goes. Jesus. How are you supposed to put that in? What's this capacitor for? That's a lost capacitor. it was for something. What's this one? I'm missing one from the chip somewhere. Quite tired today, so I think I'm just going to do an hour. That was an hour. As you can see, the board's coming on a bit now. There's some revelations about things. I think the SD card is actually going to come through the back of this, through that and to the panel, just to give us lots of space. Because if you see, it's this board here. There's a bunch of components here, I don't know what they are. I think in my next session I'm going to focus on laying out the connectors so we can get our head around it. And then the next session after that I'll really go to town on making this, all the condensed circuitry work, basically. Yeah, and you can see is that the wrong... No, they're not wrong. I don't know if these are the right size chips. Anyway, thanks for watching. Catch up next time. Bye.